Okay, so it's after spring break, and as I was telling you in our first series of these modules involving SMS, there's actually three. This is the second of the three. The exercise that you did over spring break or the week before spring break hopefully prepared you for or more fully ingrained the idea of structured analysis. Whenever we've got a database or another phone or something to refer to, then figuring out and mapping the SMS messages is fairly easy. But it is often the case that we don't have that information, that it is chip off, or we can't afford to get the next phone, or we don't know what the phone is, or there's several scenarios where we don't have something to compare to, and in that case we have to do an unstructured analysis of the SMS. We have to just poke around and pull out messages and do the best we can. And the process that we're going to follow through here kind of also falls under the triage category. Maybe I should have added that to the title, in that in the end the final product we're going to have is not going to have a lot of detail to it. Perhaps not even enough detail to be admissible in court. But it's the best we can do, and it's a good starting point. So that's what we're going to cover in this module. I'm going to use two windows here, or I'm not going to go full screen and do PowerPoint because I want to be able to switch between my VM of Santoku, which is my understanding you already have, and the slides. So before beginning this module, I'm not going to do separate hands-ons because because this one is so integrated with the hands-on material. I'm just going to do two windows up at the same time. So before beginning this module, you need to have Santoku installed in some fashion. You need to have access to a thumb drive with the image file that we're going to be working with, and that image file is called sch-u450.bin. I will leave it up to Joan as to how that file can become available to you. It's a 2 GB file, so it's considerable. The way that I've got it set up here is that I have installed, I put it on a thumb drive, and then I've given the VM the access to the thumb drive, and I've navigated to the directory where the file is at. Now let me walk through that procedure real quick. If you need refresher in how to use Linux in the command line, then go back to the Linux module and review it, because a lot of the things we're going to do today are really going to involve that module. So just to make sure that you've got things set up, I'm going to remove the thumb drive so that I can restart this whole process. Okay, so step one, you need to get a thumb drive and you need to have that file on it. The reason that you have to have a thumb drive is because if you're in a VM, you've got to give that VM access to the drive where the file's at, and you can't do that to the internal drive. So you have to connect your thumb drive to your machine. If you're using a Mac, then you're also going to have to unmount that drive. After it's mounted, or after you've attached, you should see in the list of USB devices, whenever you click on this little symbol right here, one of them you should see is the thumb drive. And oh, mine's not loading. I have to go and eject it actually from my Mac so I can come back over here and see now it's in black, and it'll let me add it now, so I will add that. You can see it blinking, it's trying to add it. This window will come up. I'm going to cancel. I want a terminal. Tell you what, let me go ahead and do that part as well. Click on the little knife down here, and I'm going to go to Accessories and LX Terminal. And let's see. I can make this window a little bigger. Display, scroll back, style, terminal font. Ah, here we go. So I'm going to increase the font just a little bit to make it easier for you guys to read. Let's try 16. Yeah, that's better. Okay. So I've added the thumb drive. So I'm going to type the command ls/dev/sd asterisk. And see, we have SDB1 shows up now. That's going to be the thumb drive for me. So sudo mount /dev/sdb1. Oh, let's type that. Correct. Okay, looks like it automatically mounted it, and it's mounted to media C4 68 whatever. So I'm going to change directories to media. Then I'm going to change directories using tab complete into the thumb drive, and then I'm going to go into the folder where I have stored the sch-u450.bin. Okay. Pause the lecture at this point and make sure that you are at a screen looking similar to this before continuing. If you need assistance, send us an email or ask for help or revisit the Linux module. Okay. I'm going to assume that you've got that window open now and you're ready to go. So let's proceed with the lecture here. So in this module, Unstructured SMS analysis. To fully recover all SMS messages, a complete binary analysis must take place. You might have messages that have been deleted. You may not be able to reverse the file system that was on the device for several different reasons. You may have to do a complete binary analysis. That's the only way to be sure to get all the text messages anyway. So even though we're talking about unstructured analysis, it doesn't mean that some kind of structured analysis took place as well. Sometimes, actually very often, we end up doing both and then comparing the results to see if we get messages that weren't in the structured analysis or in the automated tool, and then we can assume those messages were probably deleted. Also, the results of chip-off is typically a binary dump, which we may or may not be able to get an automated tool to parse for us. So this module presents a basic procedure for SMS triage that's useful in those circumstances. Why triage? Because we will not be reverse engineering the file system or the file structure. There's actually no guarantee we're going to get every message. We're going to do our best, and we have to make sure in our reports that we say that we did our best and provide the limitations of the analysis. But overall, there's no guarantee. So, in further analysis will need to be done to determine timestamps, inbox, outbox, and sent. Sometimes it's good enough. We talk without getting that information. It depends on the messages. However, we talked about this in class the other day. As Joan always says, everyone looks like a jerk whenever you read their text messages. So, you have to be careful whenever you're doing this type of analysis. Think about your phone and the text messages that you write. Are you always serious when you say you want to kill somebody? Or whenever you're maybe being flirtatious with somebody? No, probably not. And maybe you're having a conversation half in text and half in something else. I mean, there could be a lot of reasons why the conversations could be misleading. So always take what you find with a grain of salt. We're going to be using Linux for this module. Linux has all the tools necessary for this kind of analysis already built into it. It's great. The command line tools are easy to modify and customize the results. And for the final product, we're going to at least edit some scripts that will allow us to filter the results, and all those built into Linux. So Linux is going to be our tool of choice for this analysis. So the method is the same method that we discussed before spring break, but since a lot of you may have brain cells that have been fried over spring break, let's briefly review. and a little bit less detailed than the previous lecture. So step 1, we're going to survey a raw image to determine if text message exists in plain text. We're going to look over the image using XXD and some other tools to see whether or not there are any text messages. Then we're going to extract samples for basic analysis. Once we find some text messages based on keywords, we're going to extract those, put those in separate files so that we can do some analysis on those messages, find headers, footers, and other good things. Once we've done our analysis, we're going to data carve based on what we find in step 2. And then we're going to examine and filter the results, which will be next week's module. So step 1, surveying the raw image to determine if text message exists in plain text. To do this, we're going to use XXD, it's command line hex editor. And we're going to use the command line hex editor so that we can also take advantage of grep and pipe. Grep is a filtering program that basically allows us to search for specific words or patterns or whatever through the file, and then it will print out only those lines that contain that specific pattern. Pipe, as we explored in the Linux module, allows us to send the output of one command and use that as the input of another command. Step 1. Oh, and by the way, you might want to look at the lab assignment, as everything that I'm showing you how to do now is necessary for completing your next 20-point lab. So step 1, create a list of commonly used expressions in texting. So you're going to sit down, you're going to think about your case, you might think about your suspect, and you're going to create a list of words. Now I say you're going to think about the case and their suspect because what if they don't speak English? Then you might want to get some help from somebody who speaks whatever their native language is. And you might want to try to find the juicy text messages first, the ones that might relate to the case. So you're going to create a list of keywords. Then you're going to search for those keywords within the raw pattern. Oh, by the way, you'll notice that the examples I have here, dude, LOL, hey, love, and I have explicitive there in double quotes. As sad as it may be, explicitives tend to be one of the more successful search terms when looking through the image. And in the sample image that we're giving to you to use, this is from a phone. This is from a real phone. It's not from a real case, mind you, but it is from a real phone that we got off of eBay or Goodwill. I don't know. You can ask Joan. And there are plenty of explicitives in it. So if that offends you, then you're probably in the wrong field. But if you'll send us a message, maybe we can find something else. But there are plenty of explicitives on this phone. So let's see. Once we have those explicitives, or excuse me, one of those keywords, we're going to write down some of those offsets so that we can further evaluate, so we can extract just that text message. So XXD, the command is going to work like this. You're going to type XXD, the name of the image file. Then you're going to send that output into grep and search for your keyword. And then you'll get line by line instances of that keyword. Here I'm using LOL in this example. LOL is not a great one. As you see on the second line, it's actually giving back a false positive. That's not actually a text message. It just happened to be a random occurrences of the letters LOL, probably not being text at all. So this one down here actually does look like a text message. So anyway, you want to try to get something, maybe at least 4 letters or so, so that you have a lesser chance of getting false positives. So on the left, when we run XXD, we're going to get the memory offset for where that's located, and on the right, the interpretation of, or in the middle, the hex, and on the right, the interpretation of that information in ASCII, which will help us see whether or not it actually is a text message. Once we've done that, we can extract samples for basic analysis. To not get the video too long, let's work on that step first, and then we'll stop, and then we'll make another video. Okay. So if I type XXD and then begin typing the image file, if I just hit enter, there's way too much information there, so I'm going to hit Control, hold Control down, hit C to stop it. If anybody will recall, you can pipe to more or less, and that'll slow it down so you can view it one page at a time. This file, by the way, is a result of a chip-off, and as I'm looking through here, there's definitely information in here. It would take too long looking at this page by page, however, to find the text messages. So instead, I'm going to hit Q to quit, and then I'm going to, as the slides demonstrated, instead of going to more, I'm going to pipe to grep. I'm going to use the word, I don't know, love, and I'm going to hit enter. This might take a few minutes. It's got to go through the entire image, looking for that. Okay, that first one, it says number rollover. That may or may not be a text message. Fail over proxy, the next one, that's not going to be a text message. It says I love you. That has a much higher chance of being a text message. Oh, look at this one down here. Out, love ya, something. That looks more promising. Okay, so you take your list of keywords and you'll check different ones out to see which ones give you some good text messages. I'm telling you, you need to extract. So that's going to be the next part, and that's a little bit more complicated. So I'm going to pause here and switch to another video. We're already at 17 minutes, and so before beginning the next set, check out each one of your keywords. Look and see which ones give you things that are likely text messages, and then when you're ready to begin the sample extraction and exploring the area of memory, then come back to video 2. When I say area of memory, look at these offsets. These are not one after the other. This is the single line in the XXD output that has that word. So we're not getting we're not getting anything right above it or right below it. We're just getting that single line. Okay, so see you soon.